normal contact. Call this is N1. First we'll list out all the forces. This will be the weight mg, then the friction. Let me give the number naming. So this is N1, normal contact N2, and there's a friction. Mu N1, I'll write it, or F1. Okay, so now we have friction, normal contact like this. What is the tendency of this rod? How do it will move? It will have an acceleration, one along x-axis. So one along x-axis, y-axis, and it will rotate about its center C. Anybody, any objections? So you can object it. Same thing in the torque, we were discussing about like what should be the angle theta for equilibrium. Here I just brought a numerical where it will have acceleration. So it's asking the magnitude of initial acceleration of NA of the rod, NB of the rod, what is the angular acceleration, all and things, magnitude, the normal contacts, all things we can determine. What are the equations? We can write it. So along y-axis, why I should put acceleration along x, along y? Any reason for this? Why not ax towards right?
Normal contact, it is acting towards left.
This N1 is acting, no, only this N1 is acting on the rod along x-axis, so x. Why can't AY upward? I think there's a common sense, no, like how center of mass here, if it is set free, no, this end will move towards left, this NB will move towards right. Definitely the center of mass will have a displacement along y-axis also. So AY, I'm going to take it. Sir, what about alpha? Under action of all this, there'll be torque is set up and it will rotate about its center of mass. Let's see what all we can do. So this is one basic assumption. This is very important. This is the important part. So let's write all the possible equations. N1 equal to M into A1. This is equation 1. Then along y-axis, mg minus, let me write mu N1. Mg minus mu N1 minus N2 equal to Ma2. Equation 2. Now about talk about center of mass. So all will set up talk about center of mass. This will be theta N2 N2 into L by 2 sine theta clockwise plus N1 into L by 2 cos theta anti-clockwise, then friction mu N1 so what is this? This should be equal to IC into alpha C N2 L by 2 sine theta. So whichever torque clockwise one, I'll take it positive. Anti-clockwise, let me take negative. Clockwise one, I'll take positive. N1 L by 2 cos theta. What is IC ml square by 12? So there's the equation 3. Moment of inertia, I'll write it. Okay, now But still, so many things are there, no? I think I can simplify this. We'll end up with equation n2 L by 2 by root 2 n1 L by 2 root 2 anti-clockwise negative mu n1 L by 2 root 2. Let me call this as equation 3. Now we'll one L will get eliminated. One more step I can simplify. ML alpha C root 2 also. This will be 6 3 into 2 or 3 root 2 this side. N2 minus 2n 2 mu. Okay, this will be minus of check it once. I think I'm right. Huh?
Yes.
Is it okay? Yeah, fine. Now, what is the next thing? How many unknowns? So many unknowns are there, no? Whose help you have to take? I think we have exhausted ourselves, no? Okay, sir, what is there? Talk about any point? No, it is rotating about center of mass. This is all. We are exhausted. I need some more equation. Whose help I should take? Consider equation. Acceleration along common normal should be equal. So as because of rotation of the rod, it will have tangential acceleration. Then what is acceleration of point A along y-axis? Should be 0. Okay, similarly, acceleration of point B along y-axis, along x-axis should be 0. So I do take help of constraint equation. With the help of that, I'll get relation between alpha and ax and ay. That constraint equation will help us to solve further the thing. So a acceleration of, I will minimize it. Yeah, now you see it. Okay, we'll take the rod. No acceleration. This will be L by 2 alpha. This is theta. This is theta. So here ax and ay. This is the point A. Similarly, at point B, it should have tangential acceleration L by 2 alpha. Alpha only we wrote it. This is ax. What is ax and ay? I'll change it. So this is ax and this is ay. This should be theta. So what is the constraint equation? Acceleration of point A along y-axis must be 0. Because the rod, the end A will be in contact. The end A will be in contact with the ground. I just picked up this problem only to explain this constraint equation. Here, very important. The end A will be in contact with the floor. Okay, fine. So based on this, now what we can write it as like a AY is equal to L by 2 alpha cos theta. Similarly, the end B will be in contact with the wall. So ABX must be 0. So what is the condition now? So AX should be equal to L by 2 alpha C. Alpha C, why alpha C? Only alpha. Okay, Okay, solving 1, 2, 3, 4, 5, we'll get the required answers. Getting so small idea based problem, huh? You could have avoided that small roller. You would have just made the horizontal surface as a smooth, vertical wall as a rough, and you could have continued the problem. I'll write down the key you check afterwards. Huh?
4123.
PQ 4123. 4123. Yeah? Let me see once. Acceleration (3 meters per second square). AX and AY will become 3 meters per second square.
4124, sir.
4124. Huh? I don't have. The friction will be 1 Newton. Yeah, the friction will be 1 Newton. This will be S, the magnitude of initial acceleration of the rod. Initial acceleration of the rod, 3 root 2. 4124. Okay, I'll slide down. We'll take the next one here. Determine the distance moved by the lower end